All right. Today we're going to look at what a series is and then use a shortcut, a test, to see if our series diverges or not. Okay. So a series is basically the sum of a sequence. So I know we've talked about this before, but we use the summation notation to tell us what term we're starting with and what term we're ending with. Okay. An infinite series goes on for infinity number of terms. Okay. So what we would do is add all of the terms a sub 1 plus a sub 2 plus a sub 3, so on and so forth, till we get to a sub n, and then it actually just keeps going on until infinity. So we're adding up an infinite number of values. Okay. So what we have to be really careful of in a sum is whether our first term starts with, if we're substituting in a 1 or if we're substituting in a 0 to get our first term, or whatever number is in the bottom of the summation notation is the first n that you plug in. Okay. So the difference between an infinite sum is that literally we are adding up an infinite number of terms, whereas a partial sum will only add a finite number of terms. So if I say S sub 1, you're only adding up the first term. Okay. S sub 2 would be a sub 1 plus a sub 2. S sub 3 would be a sub 1 plus 2 plus 3. Okay. Whereas S sub n goes on for infinity. Okay. The definition of a convergent series is for the series, okay, the summation of a sub n from n equals 1 to infinity, the partial sum is given by S sub n is equal to a sub 1 plus a sub 2 plus a sub 3 till the matching n. If the sequence of the partial sum of S sub n converges to S, then the series also converges. So basically, if we write the rule for the equation to add that gives us the pattern to add the values together, which we'll do in a second, and that equation converges, then the series also converges. Okay. If it doesn't, then it diverges, basically. Okay, so let's do a couple. We're going to determine if the series is convergent or divergent. Okay, so what I need to do is look at the partial sums so that I can figure out what the equation for the series is. Okay, the sequence of the series. So first I have S sub 1. Because that's the first n that I'm plugging in, I'm going to plug in 1 over 2 to the 1. That gives me 1/2. Okay, S sub 2. So I get 1 over 2 squared, which is 1 over 4. Okay, S sub 3 is 1 over, oh wait, I did this wrong. Sorry. Okay, so S sub 2 is A sub 1 plus A sub 2. So a sub 1 is 1 over 2 plus 1 over 2 to the second, which is 4. So 1/2 plus 1/4 is 3/4. Okay. S sub 3 is a sub 1, 1/2 plus a sub 2, which is 1/4, plus 1, and I'm going to plug in a 3 for n, giving me 2 to the third, which is 8. This adds to 7/8. So what I'm trying to figure out is if I put all the values of the sums, the partial sums, okay, as a sequence, what is the value of S sub n? So is there some rule that will give me each one of these outputs? So this one's not too bad. I can see that, like, I'm trying to get S sub 1, S sub 2, S sub 3 would give me each one of these outputs. So what I'm going to get with the denominator is 2 to the power of n. So 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. The numerator is just one value off from the denominator, so it would be 2 to the n minus 1. Okay, so this one wasn't too bad. I could take all the values and actually figure out what my nth term would be if I wrote all the partial sums in a sequence. So now if I figure out convergence and divergence, I'm going to take the limit as n approach, or sorry, I'm going to write this as the sum of 1 over 2 to the n, because that's what we started with, is equal to the limit as n approaches infinity of the nth term of the sequence. Okay, so that would be the limit as n approaches infinity of 2 to the n minus 1 over 2 to the n. Okay, and what I notice is they both have the numerator and the denominator's highest power is both 2 to the n, so both exponential. So this is an eats DC situation. I basically have 2 to the n over 2 to the n, or 2 to the infinity over 2 to the infinity, which gives me, this is eats DC. They increase at the same rate, so I'm going to have a limit of 1. So this series, the sum from n equals 1 to infinity of 1 over 2 to the n, converges to the sum of 1. Means if we basically add up all of these terms together, we're going to equal 1. Okay? So there's like a finite amount of area. So we're not going to grow forever. We're going to approach an area of 1. Okay, sure, we can do this one too. Okay, so we have S, this is my series. Okay, we're saying the sum from n equals 1 to infinity of 1. So S sub 1 would equal 1. S sub 2 would equal S sub 1 plus S sub 2, which is 2. S sub 3 would be 1 plus 1 plus 1. There's no variable to plug into. So this is a really easy one because we have 1, 2, 3 is our term. So we're going to try and figure out the rule for S sub n. This is S sub 1, S sub 2, S sub 3. So we end up with just n, right? Yeah, n. So we're going to figure out if we converge or diverge, we do the limit as n approaches infinity of n, okay, because we're taking the nth term, we're taking the limit of the nth term of the sequence, okay? So n is going to approach infinity, so the series, the sum from n equals 1 to infinity of 1 diverges because it goes to infinity. Okay, all right, so one more. I'm going to start with 3 because that's what my n says. So S sub 3 is equal to negative 1 to the third times 1 over 3, which is negative 1/3. S sub 4 would be the next term. So negative 1 to the, we need to add we need to add the term before. So negative 1/3 plus negative 1 to the fourth times 1 over 4 for the 1 over n. So that's basically negative 1/3 plus 1/4, which gives me negative 1/12, I believe. Okay? Yeah. Now, S sub 5 are the two terms before, so negative 1/3 minus 1/12 plus negative 1 to the 5th power times 1 over 5. So that's negative 1/3 times minus 1/12 minus 1/5 for our next term. I messed this up. Sorry. This needs to be negative 1/4 because I'm adding this part. Negative or positive 1/4. So negative 1/3 plus 1/4 minus 1/5. This one's a pain in the booty because this is going to equal negative 17 over 60. So my sequence, the sequence of the sums would be negative 1/3, then negative 1/12, then negative 17 over 60. So I need to write the rule for S sub n so I can take the limit. But honestly, it can be very difficult to find the rule for the nth term of your sequence. So what we do is we poo-poo on this idea and we look at a list of shortcuts or tests that we have to see if the series converges or diverges. That way I don't have to always come up with the nth term of the sequence. Okay, so we have, before we look at these shortcut rules, so we're going to come back to this. I'm just going to we're just going to chill on that. Okay. So we do have some properties of infinite series, and then I'll have another video for our first test. Okay. So the properties of infinite series are as such. If you have, if your series adds to a finite number, and a second series adds to another finite number, then that should say 2. Then we know the following about these rules. So if I have the sum of a constant times your series, then you can multiply your series sum times a constant. Okay, we could add the two series together, and then the number they converge to, the numbers they converge to, you can also add together. Same with subtraction. That's what number 3 says. Okay, so in the next few chapters, this chapter, we're concerned about whether a series converges or diverges, and then sometimes we can figure out what value it converges to, sometimes not. Okay, so I'll have another video in a second. So we're going to look at our first test.